Today is about continuity. The process of finding the gradient, as we know, is about finding the tangent when we find the derivative. Find the gradient of the tangent by differentiating. So some graphs may not be differentiated in places. Okay, why would that happen? Let's have a look. It cannot be differentiated at a point that is discontinuous. Okay, if you have a break in your graph or an asymptote or something like that, you're not going to be able to find a gradient there, are you? It also cannot be differentiated if there is a sharp point rather than a smooth point. Because if you're trying to draw that tangent on there, where is it going to go if you've actually got two different slopes kind of coming together and meeting at a sharp point? So these first couple of graphs here, it says find the points where the following graphs cannot be differentiated and justify your answer. So this is a hyperbola, we know this graph, and it has some lovely curves there, which is not a problem. But the reason that this one cannot be differentiated is because we have that asymptote. Okay, so at that asymptote where x is equal to a, it is discontinuous. So at that point, we cannot find a gradient. The rest of it we could, just at that point, we cannot find the gradient because it's discontinuous. Looking at B, again, nice curve, but check out this point here. When you see an open circle like that in a graph, it means that there is a little break in it, and that is also a discontinuous point. Okay, so we cannot differentiate where x is equal to b. You see the b down here? That's where the b is. So at x is equal to b, it is also discontinuous. Just another way of doing it from an asymptote. Discontinuous, yes, two U's. Didn't I do it in the first one? Discontinue. Oh, I must have been tin-u and then os. It's better right the second time. Okay, last one. Not discontinuous. Okay, there's no asymptote, there's no break in this graph, but the problem with this one is the sharp point. Okay, because remember, if you were trying to draw a tangent to that, you're like, which way should it go? They've got lines coming from both directions. So at that sharp point, which is where x is equal to c, our reason we can't differentiate it is because it's a sharp point. Okay, so they weren't really kind of questions you're going to get. It's just kind of identifying what the different types of points are. Over the page is the kind of questions we need to do. Find all the points where the function below is not differentiable. So yes, it's kind of obvious with the letters that are there, isn't it? Okay, so obviously sharp point here at A, can't differentiate that. Another sharp point at B, and then a break at C. So we can't differentiate at x equals A, B, and C. That was too easy, wasn't it? Question 2. Consider the function. And we've seen these before. We have two different equations, and depending on the x values depends on which equation we use. So when x is greater than or equal to -1, we have the function x squared. When it is less than -1, we use 2x plus 3. So the first thing we're asked to do is to sketch it. Okay, so I'm going to start with the graph that has the equal to sign on. I'm going to start with the parabola. Okay, so draw up my little Cartesian plane here. Its y is equal to x squared. We should be very familiar with this parabola. So starting with x is equal to 1, because that's the first x value that I can have for that parabola, because it says x is greater than or equal to 1. If you sub 1 into x squared, 1 squared is 1. So there is my first point right there. Then, actually, sorry, it was -1.
Yeah.
Oh, thank you. I need that point anyway. I did need that one. But it's a -1. This is greater than -1. So let's sub -1 in. -1 squared is +1 as well. So that's here. If I sub in 0, we know that's going to be 0 because we know that this parabola looks like. It goes like that. So from -1, for increasing values of x after that, I've got the arrow on the end to say it will continue. It's going to continue going up down here. But from this point here, it is now going to break, or maybe break, we'll have to wait and see. It's going to change to this second equation. Okay, I now want to sketch 2x plus 3 for all the values less than -1. Let's see though if there is actually a break. What happens if I sub a -1 into here? 2 times -1 is -2, plus 3 is 1. There's actually no break. It does actually start here at 1. Okay, let's sub in another value. Let's sub in -2. 2 times -2, -4, plus 3 is? -1. So let's go down here. So at -2, down here at -1. And by looking at the equation, 2x plus 3, hopefully identify that that's a straight line. So you just need to be able to join those two dots together in a straight line like that. And they are actually meeting at that point. So make sure that there is a coloured in dot here. If there was a break for some reason, remember we use those open circles. So the part B says to state the domain and range. Domain are the x values. So yeah, I can have every x value that I want. The line's going to continue going this way, and the parabola's going to keep going that way. There's no x value that I cannot have. So it's all real x. The range, exactly, it's all real y as well. Because my line's going to continue down in the y, in the negative values, and my parabola's going up. So all real y. That wasn't very exciting. Okay, part C, where is the function discontinuous? Or where can it not be differentiated? So there's actually two questions there. First of all, where is the function discontinuous? Nowhere. It's actually a continuous graph. So let's say that. The function is continuous. Where can it not be differentiated? Okay, so even though it's continuous, there's still somewhere where it can't be differentiated. Where? The -1 because of the point. Okay, but it cannot be differentiated at x equals -1. That's it. That's the key idea. You're just looking for breaks in your graphs or points in your graphs to look for spots that you can't differentiate. That's all continuity is about. The next one kind of goes on to that. We're going to be differentiating things that may be discontinuous in places, but that's our last one for tomorrow.